Hey guys, hold on. Wait, there we go. All right, we are live.
All right.
Cool. So, George, how are you doing on this fine evening? Hey
Doing
guys,
good.
hold on.
I have to
Wait.
mute the YouTube video because I heard us on like the repeat and I was getting
Oh,
freaked
yeah,
out
yeah.
hearing like
It's
fake
actually,
voices.
that's going to be a big problem if I didn't pause that, because it's pulling desktop audio, so it would just go in an infinite loop, and
Oh,
that would
geez.
not be good. So, I really shouldn't be monitoring the live stream from my own computer. Should be watching it on that guy over there, but
Yeah,
amateur hour over here. What are you gonna do?
we're learning. We're learning.
That we
Are we
are.
still live or
We should still be live.
okay?
Uh,
For anybody watching, are you guys able to hear us okay out there?
all I think it's like 4 people, 8 people.
I'm seeing seven.
Oh
I'll
wow,
take seven.
that's pretty good. One of them's you
There we
though, so
go,
that's
seven.
6.
Yeah, it's true. I guess I am watching technically. I'm not kidding.
All right, so how do you want to start off? Do you want to talk
Um,
about how your Harry Potter experience went?
yeah. So for I guess all of those guys who are watching from the last video that
I'll
um
try and pull it up.
where Winston CNC'd a pretty sweet Harry Potter wand, and we were trying to um, remake interactive Harry Potter wands for Universal World, the Harry Potter world at Universal. It did not work out so well. I guess where I guess the reflectors that we we were using just they weren't receptive to the system at Universal World. But we're not quitting now. Oh, there I am. There, there's this is a video on my page of we made the wand three different ways. Winston making it with the CNC, and we were trying to make it pretty cheap so that we don't have to buy the $50 wands from Harry Potter World. So all in all, it didn't work. But I'm not giving up yet. I'm trying to figure out what went wrong right now, and um, yeah, I mean that's pretty much it. Wait to hear more once we give it a couple more test
We're
tries.
gonna have to figure out a way to like see like is it a certain like wavelength or type of reflector? Because I really want to figure this out.
Yeah, I mean, like Dr. Chris, a friend of ours from work, tried actually bringing some infrared LEDs and just trying to create his own source rather than making a reflector. That didn't work either. So we're not in the right wavelength. Um, for all those out there that kind of understand infrared systems and how they work, there's another common wavelength to try out that we can try. And then, honestly, I'm about to buy one of these wands and chop it open and see what they have inside of theirs and kind of give that a shot.
Yeah. Actually, I might know someone at Disney. I'm gonna see if I can pick his brain on that. I'll let you
Oh,
know if
that'd
I
be
figure
great.
anything out.
Yeah,
He might
Disney
be
probably got spots at
contractually
Universal trying to
obligated
figure
to
that one out.
not reveal his secrets, though.
Oh,
Um,
geez.
Hello,
What's up,
David. What
David
part
from
of Central
Central Florida?
Florida are you from? I spent 3 months in Orlando, so I kind of know the area. But I was also there during the superior time of year, which is winter when it's not humid as heck.
So yeah, so that those wands didn't work, and we'll keep trying because I want to make sure we get a solution out there. I'm sure everybody else out there doesn't want to spend $50 for a wand to get do the whole experience at the Harry Potter worlds.
Yeah. All right. Um, so we're 3 minutes in. That's pretty good. We're killing a lot of time. So let's dive right into it. So today I want to
But
just go over some of the basics of Fusion 360. I know a lot of people they get started with Carbide Create or Easel, and they just use that. They do 2.5D milling or 2D milling, which is basically you draw a vector and then you trace on that line. And so you can cut out signs pretty easily with that, but if you want to do more complex shapes, you need a proper 3D modeling software. And Fusion 360 is a great option because it's free for hobbyists and students, but it can also be pretty daunting. And so the interface you see when you first come in, it's filled with buttons. It doesn't look very friendly compared to something like SketchUp. I actually had the opposite opinion when I first started using Fusion. I felt like it was too basic. Like if you ever look up like what the SolidWorks interface looks like, it's got so many more buttons, and I love that. It's got like the first
Yeah,
order
I was a big fan of
retrievability.
SolidWorks back at school. Actually, that's what we ended up using in school a lot.
Like
I was a
look
huge
at the
fan of
features
SolidWorks.
tab. Like you get like extrusions, cuts, like holes, like all your modifications, all that just to modify existing geometry. Whereas you look on
Yep.
Fusion, it's like, oh, it's right here. It's this modify drop down. And so for me coming into this, I was like, oh man, it's so limited. It's so basic. Like the features are so hard to get to, but they're
There's
actually
not
there.
enough to use.
Um, so let me first talk about the interface itself, how I like to get it set up, um, and then we'll talk about some of the basics of like navigating, and then maybe we'll do a little modeling at the end. So you have a whole bunch of tools that are arranged, they're grouped by how you use them. So if you want to make a sketch, you have the sketch section, um, and all these tools are used to draw shapes. So I can make circles, I can do rectangles. Um, you have additional features down here. I could put some text down, I could make a spline. Um, and so everything in the sketching window is in
Beautiful.
the little sketch tab. And what I like to do is you can add commands to your toolbar. So like I like to use a center rectangle very often, and sometimes the 2-point corner to corner rectangle. And if you hover over different rectangles options, you can add them to the toolbar. And so you can put what you need right there front and center if you so choose.
Oh, I didn't know you could
Um,
actually add more to it. That's
yeah.
useful.
So like
I would add like all
everything
the
I need,
dimension tools because
like 90% of what I need, I keep right at hand on the toolbar. So you can sort of just build it out a little and just make it custom tailored to you. And so that overcame a
yeah.
lot of my like, oh my god, it's so basic mentality, because the features are there. It's just the first order retrievability. Like, hey, I want a square. You have to like
hmm
click through a menu to get there. Now it's just one click and you draw it, which is a lot nicer. Um,
Yeah.
so that's your sketch pane. And then from the create tab, you can do a whole bunch of things. The most common one is your standard extrusion. Um, but you have some other ones, like you can do revolves, and lofts are fun, a little more complicated. I haven't done too many of those. Pattern, that I've used a lot.
hmm
Um, just like if I want to make like 10 of these cubes, like I can do that. I'll just do a rectangular pattern, select the body, and then I want to make a pattern in, let's say, that direction. Like, give me
hmm
3, give me 5, however many it
So
may
so
be.
how do you do that right there? That was a pattern tool.
Yeah, so I'll get more in depth into this later if you want, but um, like if you're doing like a circular pattern or like a rectangular pattern, this is a really easy way to duplicate something. Um, so it's rectangular pattern. You can pick the type
hmm
of object you want to replicate. So you can do faces. Like if I make an extruded cut, I can duplicate that cut multiple times. Here I'm going to be doing the bodies selection. So I'll pick the box, and
hmm
then I'll click on the direction. Which way do I want to make more of these? So I could do that
hmm
way, or I could do this way, or you could do two directions. I don't
Can
know
you
if
revolve around like a certain axis?
you
Because that would
can.
have been useful
That's a
for my lamp I was
different
making.
command. So that's the circular pattern, and
Oh, cool. Okay.
you pick your body, you pick an axis. You can do a like one of the vertices or like one of the origin axes.
hmm
So if I want to put like 6 of these or something,
Jeez.
it's right there.
That would have saved me a lot of time couple of days ago.
And so using rotational symmetry or something is a really easy way to model something that's like got a lot more complexity to it. You can just sort of do like a quarter of something or half of something and then revolve it around.
Exactly.
You got less geometry to play with. I think it's a little faster when you regenerate. So if you make a change parametrically, it propagates through a little faster. But don't quote me on that. So that is your just basically your geometry creation. How do you go from 2D, which is the sketch, to 3D is your create. Your modify tab, you've got options to put a fillet on something. So let's do a 0.05-inch fillet. Let's do like a chamfer of like 0.1 inches. Oh, it can't go below that radius.
My headphones are dying. I gotta grab a new pair. I guess these
Oh,
batteries
man.
are bad. My bad.
This
I'll be
is
right
what's
back in a
wrong
hot
with
sec.
wireless headphones.
The wireless headphones.
So you can, when you're applying these modifications to geometry, you can either type in a specific value, or you can just manually grab the arrow, adjust it if you want to do it more freeform, sort of like sculpting. And that's basically all there is for the modify tab. I put the fillet and the chamfer on here because those are the most common ones I use. But sometimes I use the move, copy, the scale feature if you want to just make something bigger or smaller. You want to make direct changes to the model like that. Yeah, that's basically it for modeling. Sometimes it's useful to create construction planes. So let's say I want to draw something. Hey, welcome back. Rocking your DJ headphones.
Yeah, my pretty old. So first pair I could find.
So if you're trying to sketch something that's not directly adjacent to geometry you already have, or one of the origin planes, you can create construction planes that just let you work in any arbitrary place in space. So let's say I want to make another cube floating above this one. I can construct a plane offset from this surface. And now I can just draw.
Okay, so that's the construct tab. I've always tried to figure that one out because in SolidWorks that was like a control and like space. There's like some quick easy hotkeys, and I didn't know how to do it here.
Yeah, so it's all in there. You can make planes, you can make axes, and just points. So once you have a construction plane, you can just sketch on that. You can create something, extrude it. Whoops. Extrude that, and now you've got geometry that's floating, that's not physically linked to the previous object.
Oh, that's perfect.
And those things, they show up as separate bodies, whereas usually if you create something and it's like, if you're attaching something at the hip, they form as extensions of like the same body. So if I do this, the join operation is active, and this face is actually part of body one.
Gotcha.
Or if you want to make it a separate piece, you can actually, let me edit that. You can do it as a new body. So it can be independent or it can be linked.
That's fantastic.
So now body
these
3 is its own little thing.
just...
Especially like if you have more complex models, being able to separate things out like that just gives you a lot more control, and it's pretty useful.
Yeah, for sure.
One of the other things that you can do, which I'm not very good at with components and assemblies, is I can just take a model that I've made elsewhere and just drag it in theory.
I think you have to click...
I haven't saved this yet, hold on.
Is that why?
And no one look, because I'm definitely not in a Bronze YouTube Award 25K work folder right now. We'll put this in miscellaneous parts. Oh man.
Man. For all those watching, if you guys have any questions as we go through this, go ahead and pop them out there. This is pretty much for anybody to learn as we go along.
So yeah, you can just drag other models you've made into the same scene and just work with it that way. So if you're making like assemblies and you've got like
Yeah.
you're modeling like one part of like an engine or something, you can bring it into your car model and just sort of mash them together. Um,
Yeah, that's what
but
I just learned from my grenade lamp projects from
yeah,
a little tip from you.
so we can either go into modeling the project that I'm going to show off tomorrow, or we can. Well, actually, we kind of need a model in order to show off any CAM stuff. How about we let me model this guy.
Yep.
I'll show you some basic CAM for that, and
Yeah,
so you
that's
can
a good
sort of
idea.
walk through from start to finish. How do you get some geometry, and then how do you apply some tool paths to it? Because that in and of itself is a pretty important workflow.
That's like the perfect workflow for a beginner too. So that's great. I mean, showing both side by side, that'll give everybody the tools they need to get started.
Yeah. I think it might just be easier if I start from scratch. The part that I'm making is hold on. Let me give everyone a preview.
Looks like one of those oven bake, uh,
Yeah,
like
it's
cupcakes.
a muffin tray for ants. So this is an aluminum part that I use to hold canisters of electrolyte tablets that I have because I'm a runner,
Oh,
or at least I think I'm a runner. And it's machined out of a single piece of aluminum. Um, got a lot of weight removed from the inside, just like an aerospace part. But it's really just a bunch of holes in a block of aluminum, and then the outline of everything extruded inwards. So that's what we're going to model today.
great.
Um, so I'm going to start from a blank canvas. I'm going to show my origin planes, and then I'm going to start by sketching out just the main body of my piece. So one thing that's sort of a mindset that I have going into this is I always model this sort of as you would manufacture it. So I'll start with a block, and then I'll remove material from it. You could like sort of just model like the entire like cross-sectional area with all the holes and then put a floor on it at the end. Um, I think it's just easier to model the block and then start subtracting material from it. Um, let's go back into Fusion.
Yeah, that makes sense. I mean, it's kind of the way we think as we're doing these things, right?
And it
Kind of
helps keeps things
easier.
straight in your head as you're going through
Yep.
these. And so like your steps as you model this in Fusion make sense. Um, what are my dimensions for this? I think it's like 5.2 inches.
We got a question here, Winston. Do you
What's up?
know a way to make the rotation snap when aligning two bodies?
Um, I think I know what you mean. Let me try sketching it out real quick. I'm gonna make a box.
Hmm.
Stop sketch. Extrude that 1 inch, and I'm gonna make another box. Extrude that 1 inch as a new body. Hopefully I can do this. So if you want to translate or rotate a part, I believe it's the move copy tool.
Yeah.
You pick the rotate, and you can set an axis, the axis being one of the vertices of the part you want to rotate it relative to. And then from there, you can just rotate something, and the relationship positionally should remain intact, except around the axis that you want. You can also, let's see.
Yeah, I'm curious about the snap. You might mean like when you're mating them. So the like I think just to mate the two edges, right? When you rotate it.
Assemblies is something I haven't actually used in
Yeah.
here. Um, let's see if
You'd
we
have
can.
to have them as two different parts, and then
Yeah. Let me see if I can just bring in a model for us to try.
for Epinoesis, Fusion 360 is there's like free trials for it, or if you're a student, you can get it free for like 2 years. But
The
other than
last
that, I think you have
I
to pay for
heard
it.
was that Fusion 360 Standard is free if you make less than $100,000 a year in revenue.
Oh, really? Oh,
Yeah,
even better. Look at that.
I haven't saved this yet. All right, so we're gonna
Unless you're making more than 100,000, then I guess.
And then, well,
And then you can
at
probably
that point,
afford
you're
it.
probably a real machinist.
Yeah, exactly.
All right, I'm gonna add a part in, and I'm gonna try and mate this. Which, fair warning, I haven't actually done that before.
Yeah, so your star is
So
working with an unknown angle,
rotation
which
snap.
that makes sense. I think you should be able to snap them using just the edges, if I remember
Yeah, just based
correctly.
on faces, you can create an interface.
Yep,
But you can also do like a revolute joint.
exactly. I think that's what he's looking for.
Um,
You can
and
tell the
there's
amount,
different ways to
degrees.
customize that. Um, let me know if that answers your question. If not, we'll try and come back later.
Yeah.
In the meantime, let's go back to modeling this brick. It's like an inverted Lego block. And then I know this one is 3.2. Let me just do a quick check just to make sure got them right. That is 4.7. I'm way off. Half an inch off. All right, so that's my rectangle, and I'm going to make a half-inch block because that's the size stock that I'm starting with. And so we've got the starting point for our geometry. I'm going to hide the origin just to clean it up a little. And now it's time to put in the holes that my things are going to go in.
Sounds good, Yashar. Good luck with that. Let us know if you have any questions.
So
I didn't know that light bulb actually hides.
yeah, that controls the visibility of objects, which is really handy.
Yeah, it's like the simple things that I don't even
And if
notice.
you have a more
Great.
complex assembly, I don't know if there's one that I can show. I'll pull up a Pocket NC setup. You can not only just manually toggle everything on and off, but you can also pick an object and then isolate it. So let's go to, what are you? If I just want to see that, I can go to isolate, and that hides everything else.
Oh, son of a gun. Look at that.
So you don't need to like go through and like deselect everything. You can just isolate or also unisolate. So it's a very quick way to undo things like that.
Oh, that's fantastic, actually. Cool.
All right. Holes in the block of aluminum. Let's go. So I'm going to start by drawing a circle. It's going to be, I think it's 1.17 inches. And then we're going to place it such that when I make a pattern with it, it's in the right place. So I know my spacing is 1.5 inches center to center. And that works out to be 1.5 inches off the x-axis and 0.75 inches off the y-axis.
Okay, great.
And so that is a circle, that is a placed circle, and to make more of these, you could just draw additional circles manually. I'll hover over the center point, pull this out, and it snaps to the same horizontal level if you want to do that, but I want to do this a little more efficiently, so I'm going to do a rectangular pattern. I'm going to select the circle as the object I want to duplicate, and I'm going to say I want you to pattern this way, and I want you to pattern this way. In the X direction, I only need 2.
I was going to say, how do you... Wow, that's... Wow.
And so right now it's saying in the X direction, it extends 1.5 inches. In the Y direction, it extends 3. You can set that distance by extents, so it's like the total X distance versus Y distance that you cover, or what a lot of us think in terms of is just pure spacing. So it's 1.5 inches in each dimension. So I think that's a little more intuitive.
Yeah, I agree.
That's kind of subjective. All right, so I'm going to complete my sketch now that I have that rectangular pattern, and I'm going to extrude each of these holes in a negative direction. Now, Fusion automatically knows that if you're extruding into existing material, it's a cut, and I'm going to extrude that down by 0.4 inches.
Yeah, I do appreciate that. I remember SolidWorks, you had that specified, or else it would just build more piece inside of the piece. It's
and in Creo, like there's like actually a button to switch from extruding positive material or like cutting material.
Yeah, it just doesn't make
Yeah,
a lot of
it's
sense
pretty
at times.
intuitive. They do a
Yeah,
lot of the thinking behind the scenes to just make it so you just click on something, pull it in one direction, and it does the right thing.
yeah, I
Um,
agree.
all right, so what are we missing from the model so far? We have fillets around the edges and a chamfer on all the hard corners.
Hmm.
So if we go back to our block, when I was modeling the our stock material,
Hmm.
what we could have done is we could have used the fillet tool to add in a fillet automatically in the sketch.
Yeah.
Um, but we're not going to do that. We're going to use the actual fillet tool. So the fillet tool works on 3D volumes and not the 2D sketch. And you can actually just hover over vertices that you can't see and it'll still highlight them, which is convenient.
Yep.
And let's
Yep.
do the point, no, that's too much. 0.375 inch radius. No, let's do 0.3125, 5/16. Looking a little better. And now we're going to
Hmm.
use the chamfer tool on all the edges. So select, pick all circles, and we'll
It'd be
do.
nice if you were able to do like a quick all edges
You can
selection. Like
actually, I think. Let me
there's like a hotkey
cancel that.
somewhere. You think?
I think that's a selection box. That just selected everything. You can filter to only pick
Oh
edges
wow.
and stuff.
Yeah, that's
Um,
useful.
but it's, I think window
Yeah, I mean
select is
it's
what
kind
you're
of
looking for. Freeform
requires,
selection.
requires a lot of work for I guess just this simple
Uh,
piece, but for bigger pieces.
yeah, that's a mess. Forget that. Chamfer, all these faces,
There you go. Nice.
0.02, done. All right, so that is the top of what we're trying to model. You'll notice that I decided to go all out and punch holes in the back to hollow it out, make it lighter, and really just make my life miserable because that's more machining in aluminum, which I really don't like.
Mhm.
But I think it makes it look cooler.
It does
So
look
the way you
cool.
do this is you have to figure out where your pockets on the top um, correlate to on the bottom. And so if you go back to the uncompleted model, you can create a sketch on the bottom,
Hmm.
and then you can switch your view to shaded with hidden edges. This basically gives you X-ray
Oh
vision so you
wow.
can see
Yeah.
where everything is. And in this sketch, you can also do one more thing, which is project the geometry onto your sketch. So I can say, take the bottom of that pocket and just trace out where that is for me on the
Wow.
bottom face.
Yeah.
Um,
That's
and so
useful.
now you have that as a reference, which is really easy. You can sketch off of it.
Yeah.
Like your lines will snap to it. And so, and you can see
That's a
that I
nifty
didn't
trick. Look at
accidentally pick
that.
the chamfer, you picked the pocket, so that diameter is the correct diameter that you
Yeah.
want to avoid. You shouldn't cut into that, otherwise you're going to have a hole through your piece.
Yeah.
Um, Now, in order to sort of extrude this and sort of hollow it out, we can't actually extrude on that line. We have to extrude outside of it. Um, and so for that, there is a fancy tool called the offset tool, where you can just pick an edge and it'll make a new line just inside or just outside of it. So from the outer perimeter, I'm just going to do negative 1/16 of an inch. And then also, I'm going to offset from, can I do multiple? I don't know if I can select, no, it's just one at a time, I think. I could
Mm.
be wrong, but we'll do 0.05. O is the offset shortcut.
Full Mailbox wants to know, can you just use shell? I don't know when he asked that question
You
though, so I
might,
don't know.
but you won't, it doesn't give you as fine control over the thickness. It's less consistent. If you want everything to be like 1/16 of an inch, you could.
Hmm.
But I want the floors of my pockets to be a little thinner. I want the walls to be a little thicker. So I want more control over how oh my God, 0.05. I want a little more
Too much
control
control.
over the thickness of each part of this.
Couldn't you just do the, so when you're doing this right now, you probably could have just done that duplicate tool again, right? The pattern tool.
Yeah, actually, you're right. Silly me. Yeah, that would have worked.
I'm learning. That's
You
good. These are
are, you
working.
are. We'll make a CNC machinist out of you yet. All right,
Yeah, it's
so
coming.
now that we've sketched sort of the space around our features that we want to preserve, we can select that and then just extrude that out. And since I know that I've got 1/2 inch to work with, I can extrude this down to maybe -0.45. So we got a 50 thou thick shell from top to bottom.
Oh, wow. Nice.
Um, it really does look like an inverted Lego. I can't get over it.
It does. Your drill bit was able to get into that without.
So
I mean, that's a pretty deep
I
pocket.
actually didn't extrude that out to 0.45.
Okay.
I had an 1/8 inch end mill that
Yep.
had 3/8 of an inch of reach, so -0.375. And so the the thickness of my shell was a little thicker,
Yeah.
but that's only because the end mill I had couldn't cut
Exactly.
as
That's what I
deep.
was wondering.
And so you're sort of limited by the tools you have, like what kind of features you can machine.
Hmm.
So the flutes on my end mill only went up to 3/8 of an inch. You could push further, but then just the shank of your end mill will start rubbing against the walls, and that leaves a less than satisfactory surface finish sometimes.
Yeah.
And it's just not good practice in general. You can buy extra long end mills for this, which are nice. You should probably have one in your inventory if you're doing things like this. But for most of us, we just have like general purpose end mills that
Yeah. Exactly.
whatever length they are is what they are, and we have to work around it. I'm going to throw a couple more chamfers on this just because, and there's too much going on, so I'm going to switch back to no hidden edges. So
Oh
that's
yeah.
a
Look
little
at that.
cleaner.
A lot cleaner.
Actually, I'm not going to do this because what I did in my other model was
Hmm.
I knew that my end mill couldn't reach in, like this distance is really tiny. No end mill is going to be able to fit in that. And
Yeah.
so if I say, let me just show you what couldn't be reached. I'm going to run a
Hmm.
quick cam operation. Um, I might as well just talk about cam now. All right, so we're going to create a setup, and a setup just encompasses all the orientation information for your model, so that toolpaths can be applied coming from the correct direction. And so if you're machining something in a face-up orientation, you want your z-axis to be up and your x and your y oriented however you want this part to be oriented on your CNC. So right
Yeah.
now, if I cut this out on the CNC, it would appear vertically. If I changed my orientation such that z was up, but then my x-axis was this way, then if I machined it, the toolpaths would be in this sideways orientation.
Oh. Okay.
So you can change the direction of how your parts are laid out like that. And then this that's the setup tab. You can say, do you want your origin to be on top? So if you're zeroing off the top of your model, that's usually
Exactly.
where
Yeah.
you want it. I sometimes zero off the bottom of my model, and so I'll pick the bottom box point.
What's the point of doing that? I guess the way you're cutting through,
So
or
if you have a board that's not like perfectly flat and you zero off like a high point or a low point, that means when you start cutting, like in some places your end mill will be like just barely grazing the material. In some places it'll be too deep, too shallow. Zeroing off the wasteboard just guarantees like that it's like exactly your end mill will
height
stop
you're
there.
expecting it to be.
So
Yeah.
like I've zeroed off things that are like 0.5 inches in some places and like 0.55.
Yeah.
And
Exactly.
if
I
you
mean, that was true
zero
of
off
everything.
the wrong point, if I zeroed off the low point and I was like, all right, I'm cutting something that's 0.6 inches deep, that means you're probably going to run 0.1 inches like into your wasteboard. That's kind of an exaggeration, but if you know that your 0 points, the wasteboard, you'll never plunge below that. So
Yeah, it makes sense.
if I stick a piece of tape under my part and I zero off the top of that tape, I will cut through my part and I will just barely graze the tape. Like it's that accurate.
Oh wow.
But for the purposes of this, we'll zero off the top. Your stock sort of just tells Fusion how much extra material you have. So like if you're doing an adaptive clear or something, it knows like, hey, I have to come in like an extra 2 inches from the side and remove all this extra stuff. Which in most cases you try and stick as little material as possible on your CNC so you have less waste.
That's a lot of waste right there.
So, but just for the purposes of this exercise, we'll pretend we really don't have a lot of material. So, to machine these pockets, assuming you have your tools set up, I have, my computer's running a little slow, a tool library for, I'm using a Harvey tool cutter. It's not the single flute, but I haven't programmed it in. I'm using a 1/4 inch flat end mill. And so when you add tools, you need to, ideally all these parameters will line up like your flute length is a certain amount, your shoulder, your overall length, just so that the visualization is correct. Which I'll show an example of later. So I'm going to create a 2D pocket in, let's say, just that one. Just the lower left. And let's just see what happens, what it looks like. I didn't pick a tool because I'm an idiot. Sort of rushing through this. 1/4 inch square end mill. And
for those guys watching, how are we doing with speed and complexity of this? You guys, let us know if you guys are understanding it. I asked this last time, but let us know what machines you guys use too, what CNC machines you guys have, and if you guys use Fusion 360, that helps us gauge, what type of tutorials are helpful for you guys.
So there's a couple things going on here that you don't normally get with like your standard carbide creator, like a basic 2D CAM toolpath. So first thing to note is you have a ramp into the material. And that's the last tab, your linking tab, and we have a helical ramp. This is just a way to sort of ease your end mill into the material. Usually in wood, it's just like a straight plunge into your material, and like so you just drill down to the depth you want to start at and just start moving laterally. That's fine in wood, plastic. It's very forgiving, but if you do that in metal, it's really nasty.
Yes, for sparks.
Or like you'll just stall your spindle. It's not good. It's like dumping the clutch in your car. So if we simulate this, we have the end mill coming in and then proceeding laterally. And you can control the step over of that here. So if you want to take really shallow passes, you can change your depth of cut. You can also change your step over. And so this controls radial tool engagement, which is something I'll talk about in tomorrow's video. But you got to balance how deep you cut and your step over size. So if we do 0.05 inches of step over, and we look from the top down, and we turn on stock, you can see that the end mill isn't like only about a fifth of it, 0.05 over 0.25 of it is actually cutting into the material at any given time. And so by changing step over, you can control how much stress your machine is subjected to at any given time. Between that and the depth of cut, those two really control like the stress on your machine. So you got to find the right balance that your machine can handle. Shapeogo can obviously handle more than the Maslow.
But the Maslow is definitely going to start moving the router sled around a lot. Full Mailbox wants to know how you calculate speeds and feeds. There's actually a lot of online tools for that kind of thing.
There's also some guy named Winston put out a really good video about it. So when I'm doing wood,
hashtag no shame for plugs.
when I'm doing wood, I sort of just eyeball it. Like with a 1/4 inch end mill, I'll just say like, hey, I'll be cutting at about, sometimes I do up to like 90 inches per minute. It depends on the density of your wood. I'll go 60 if I'm being a little more conservative. And I'll run at about maybe a 2 or a 3 on the Makita dial, so like 16 to 20,000 RPM ish. And
Yeah.
I'll start with a really shallow pass. I'll do like maybe a 16th of an inch, and if it sounds like I've got a lot more under the hood that I can tap, I'll just manually, or I'll crank up the feed rate, because in Carbide Motion 4 with the Gerbil version 1.1, you have a feed rate override. So you can start at 100% feed rate. And if you think, oh my God, like my Shapeoko is cutting through this like butter, you can actually click on the buttons to increase feed rate and jump up to like 200%.
Yeah.
But like there's always a lot of fine tuning feed rates. So like if I make one of something and I was like, oh, that's too easy, I'll plunge a little deeper. I'll do like 0.125 inches. Feeds and speeds at the hobbyist level, they're kind of like NYC CNC calls them recipes, and it's really true. There's an analog like sort of artistic side to just fine tuning these and getting them just right. But in metal, you really want to pay attention to chip load and surface feet per minute, because those two parameters sort of dictate the physics of what happens with your cutter. So surface feet per minute, for those of you that don't know, is sort of the tangential velocity of your end mill. Like if you put like if you had like a radar gun and you were measuring the speed of the cutter like right at the very edge, the tangential velocity, that's surface feet per minute. So like aluminum, I think you're aiming for like about 800 surface feet per minute. So if you put your end mill horizontally on the ground and like ran it like a wheel, it would pull itself forward 800 feet in 1 minute. It's a very literal definition. And so that speed is sort of like informs like the friction, like how the material shaves off. And then the chip load is how deep into the material you cut every time a flute comes around. So if you have 2 flutes on this end mill that are spinning, as you... This is going to be really hard to explain. As the end mill is rotating, it's actually rotating like this. Every half revolution, a new flute comes in contact with the material. And so every like millisecond or whatever it is, your end mill incrementally moves forward. How far it moves forward before the next flute comes around is how big a bite that flute has to take, and that's the chip load. So the smallest chip load you should have is 1 thou. That's sort of a guideline that John Saunders said, and I hold to it. And that's actually, for a lot of materials, the harder materials that I cut, that's what I shoot for. So if you look at this toolpath that we made, with at 1600 RPM, we're at a surface speed of 1,000 feet per minute. In aluminum, I'll probably be cutting just at the minimum, so 10,000 RPM.
He wants to know how you set it in 360.
So in your tool tab, when you're setting up a toolpath, it'll actually calculate out for you what your SFM and your chip load are. So if I say, hey, I'm using 10,000 RPM, it'll say, hey, your surface speed is 654 surface feet per minute. If you have a cutting feed rate of 75, your chip load is going to be 2.5 thou. And so if I want to aim for 1 thou, just take a smaller bite of the material, go a little easier on my machine, I'd say let's aim for like 35. Or you could just directly say, hey, I want a 1 thou chip load. And it'll say, all right, you need 30 inches per minute. So these values, these parameters, they all update dynamically. So just feel free to just drop in whatever you need to in order to get your necessary feeds and speeds. But also know that they're kind of guidelines, so you can sort of undershoot or overshoot. For the aluminum project that I made, I was using 650 surface feet per minute. The recommended is 800. It's a function of what your spindle can reach. Some bigger CNCs, they can't hit like router speeds, that's too fast. So they have to shoot for a slower surface feet per minute. It's a balance, and there are more guidelines because you can't always hit the exact parameters you need. Thanks, President. Thanks,
Yeah,
Prozone
look
HD.
at that. Got a fan.
I know, it's pretty awesome. You'll have fans too one day, George.
One day I'll get my fans.
Was there anything in CAM that we didn't cover that you think would be useful? All right, so let's say I'm gonna go through,
part, right?
And yeah, we can. But I'm just gonna say we have a toolpath. How we export this to run on our CNC is the post process button. So you can highlight what you want to export, hit post process, and then this is where you select your post processor. And for Carbide 3D machines, we have our own post processor. For Pocket NC users, you got that. Other mill, another hobby type machine. And so you got a really generic gerbil post processor. These are all built into Fusion 360 already. So if you're wondering like, hey, like is Fusion 360 compatible with Shapeoko or like Nomad? Yes, it is. This is where you select the right flavor of G-code to export.
Unfortunately, there's no Maslow there yet, but...
Yeah, but you guys...
Hey, Vanessa! You're the best, Vanessa. You see, I got a fan out there.
Unfortunately, someone's inflating your ego.
Fantastic.
Simple pocket. All right, so that's basically the gist of how you start from a model and you end up at a toolpath. And one thing I like to do is visualize that toolpath. So OpenSCAM or Commodix or like NC Viewer, these are all tools you can use to just open a G-code file and see what it looks like. So here I can see like, hey, my origin's here and I'm machining a pocket in the lower left corner. And you can sort of just use this as a gut check to make sure that what you post-processed is what you actually wanted. I get a lot of people who say like, hey, like I made a toolpath and for some reason it's like cutting too low or too high. You drop it in here, you say, hey, like I'm looking at the toolpath and the origin's up here and the first cuts are down here. So you sort of know like, hey, I'm gonna be cutting below my origin. And you can use that to sort of just figure out like, hey, did I set my origin right? Is it wrong? Is it in the wrong place? Like, why is my part cutting like all the way in the wrong corner? It's probably an origin setup issue, like your directions are reversed or something. And so a quick visualization tool can help you figure that out before you make a mistake on your CNC that's a little more expensive.
Do you think this is better than just using that Fusion 360 simulation? It gives you a different perspective, I guess?
So this, like OpenSCAM, or it's now called Commodix, it works with any G-code. So if I were to make something in Carbide Create, the simulation features in that aren't as advanced. And if you're doing something really complex, I've heard people say that like some like thin lines sometimes don't show up. And so visualizing it in a third-party viewer gives you that extra gut check. Even though like something might not show up properly in Carbide Create, it'll show up in that simulation. It's always good to have a tool like that around that you can call on.
Yeah, I agree. I mean, there's even some cases for like the Maslow, and I'm sure for other CNC where like, you know, you're taking somebody else's G code. I guess it's just a little bit faster, I guess, to upload it like that. See what it looks like.
So same thing as with the modeling workspace. You can customize like what shows up in your CAM window. I like keeping the contour, the pocket. Those are my two go-tos. Also the trace function. So you can create an arbitrary sketch and just write out or just trace out what it is. So this is good for engraving certain things. That's how I made my dog tag
What, you
toolpaths.
could like actually type out like a word and it'll trace it into.
Yeah, so you can engrave words. You can also trace words. So let me show you. This is
Yeah.
getting more. We're going all over the place today.
Yeah.
Um,
Very broad and wide
but
tutorial here.
I mean, my ultimate goal is to just get people to realize what's out there, so that they know what questions to ask. Because if you
Yeah.
don't know like what tools are available to you, you have no idea where to start.
Yeah. Agreed.
So with the trace toolpath, what you do is you just you pick a contour that you want to follow. So in this case, I picked the corners at the bottom of these extrude patterns.
Okay.
And then what happens is your end mill will literally just go straight to those locations. And for this, I just invented a
Yeah.
really skinny
Yeah.
end mill,
I see that.
just to visualize exactly where this is going, sort of like a laser pointer. And it'll follow that line, that profile exactly. And so that's really useful for when I was engraving, just cleaning up the outer edges of my shaded regions.
Okay, and then you use the same kind of tool paths you had before for actually engraving it, right? You're doing
Yeah,
contours, I'm assuming, and
so drag engraving is a little different. You have basically just a pointy scribe that scratches the material exactly where it's placed.
oh,
Whereas
cool.
engraving, like mechanical engraving with a
Yeah.
V-bit, that's a little different. That requires like the engraving toolpath. And I'm going to drop in I programmed it as a countersink.
Hmm.
Apparently that's not working. I think it's because my countersink has... No, I lied. I have no idea what I'm doing. An engraving toolpath. Let's see if we can get this to work. How about a chamfer mill? Does that work? It's reversed because my setup
Yeah, I
is
see
wrong.
that.
So if I
Yeah.
drag that, you can create different setups with different orientations. So the front setup of my dog tag is Z up. I created a second setup, which is Z facing the bottom. And so if I move a toolpath from one setup to another, it automatically takes into account the new orientation of it.
Oh wow, look at that.
So this is how I do double-sided machining, actually. And so an engraved toolpath will do that fancy V carving that you need to get like really sharp corners and stuff. So if you simulate this out with stock, you can see just how it's coming in, and anytime now. And tracing out and following the edges of
Oh, that's awesome.
your corners.
I think that I'm gonna have to wait for that one day when I actually get maybe a little bit more detail to the CNC.
Yeah, well, I mean, you can do big things. Like if you do a big sign or like a
Yeah,
street
like a
sign
giant sign.
size thing, you could pull it off. So V carving, great feature to have on a free program. Fusion 360 will do it for you. Carbide Create also will, and in Easel you can, but that requires a subscription to that premium tier or whatever it is. But you do get
Oh,
a couple
really?
hours of usage from it per month for free.
That's pretty good. You also got another question about simulating, I guess, a load in Fusion.
So
Holding a load, I guess.
what?
Pro design.
I haven't actually used the simulation in this.
Yeah.
I know it's pretty powerful, but I've just never had a need to. I haven't designed structural parts. Most of my stuff is like cosmetic,
Yeah.
like the lightsaber that you're going to see in 2 weeks, or that you've seen in a previous video, the Elder Wand. Like there's a lot that you could do. Just like you could see if like it's going to deflect too much, or. But for the most part, like I don't care. I'll just make it. If it breaks, and I'll fix it later.
Actually, it would have been interesting for the Elder Wand to see how weak that tip point was that you were
Yeah,
cutting,
I was pretty
right?
worried about that, but it's really difficult. Well, you can figure out the stress, but you won't actually figure out if it breaks or not because
Yeah, you're
um,
right.
the wood
Yeah.
grain is so different in each direction.
I don't know if it's a little hollow and no. Yeah, I mean it's
And the free version of Fusion should have 2D and 3D toolpaths. What you guys are missing out on in the Ultimate Edition is the multi-axis stuff for 5-axis machining, and I think also 4th-axis stuff.
so that's really meant for bigger machinist type
Yeah,
of
so
things with
like your
experience.
basic 3-axis CNC should be covered under the standard license of Fusion 360.
Yeah.
Um, so yeah, these are basically the 4 2D toolpaths I keep on the shelf, and I have adaptive, pocket, and contour for everything else.
Keith, if you joined us at the beginning, we gave a little bit of a debrief on Elder Wand. We're not done trying to make it work at Harry Potter World, but it did not with that the original plan. It was, yeah, yeah. Well, there will be more attempts coming out real soon as we try to figure out how to crack the Harry Potter World's technology.
I feel like they're either like filtering for like very specific frequencies or something, but they're
I
making it
think they're
really
filtering
difficult.
for like exact, like a really close diameter of that reflection.
I read
I
that someone like looked really closely at one of those things, and there's like a sort of a black glass bead at the end,
Yeah, that's exactly what it
which might
is.
serve to filter
And
certain frequencies out.
and the dome shape of it is it's much more different than the reflectors that Oswald had recommended in his video. So it's just too different. I really think I'm gonna end up hacking apart one of these Harry Potter wands and then getting there. Vanessa wants a class for Harry Potter wands and fusion. I mean, that'd be a cool one down the line. You know, after we get the basics out there. That actually we did that in the first video.
I was actually
Vanessa.
thinking of trying to make a different wand model just because I had that perfectly faced stock ready for two-sided machining,
Yeah.
but I just don't have the time before Maker Faire to do that. Um,
When is Maker Faire?
it is May 19th and 20th, I believe. And
That's coming up.
um, my understanding is that for those of you who are Carbide 3D fans, they won't have a booth there, but they will be there. They'll have a presence there, so just keep an eye out for that. You might find Edward Ford walking around Maker Faire.
And Winston will be there, so you can try and hunt him down.
I will be. Might have something to announce about that soon also.
Oh boy.
Maybe a meetup of some sort? I don't know.
There you
Um,
go.
anyway, before we sort of wrap this up, does anyone have any questions at any point about
Oh,
the sort of
we got a
workflow
question.
that we have?
I'll let you
Um,
read that one.
okay, so this was sort of a problem that I had. I'll explain in tomorrow's video. Is when you're actually, I'll pull up a video of someone who I respect for trying this, but I am really glad that I wasn't
As
the one
type
trying
stores will
this.
hop into Google.
Trochoidal Milling on the Shapeoko by Nick Charlton. Um, I know him on Instagram. So he did some fairly deep machining on the Shapeoko, and he didn't do anything to clear chips. And so you can see like a bird's nest of aluminum chips like
Seriously.
forming in that hole, which is just, it makes me cringe a little bit.
It's terrible.
What you would ideally do, because the more chips you have, the more you might recut them, or they'll just weld or bind inside your cutter. I can't watch this anymore.
Yes.
So what I do is I take a little compressed air, I blow into it when it starts filling up, I drip a little WD-40 in it before I start cutting. And what you can do, you saw in here, he's got really long chips, and that's because these chips are basically the full depth that he's cutting at, plus a little more because of the helix angle of that cutter.
Yeah.
So you're sort of getting the diagonal distance of that height. as chip length. So the shallower cuts you take, the shorter chips you have and the less problems you have, but it's also a little less efficient. So you can see my setups, my first setup. These are the cuts I ended up taking. There's step downs of, I think, 1/8 of an inch or so. And so I didn't cut all the way down. I wanted to do 0.4 inch step downs and milling. Jeez, George, so inconsiderate.
That's the house phone just going crazy now. Great.
So yeah, you can take shallower cuts so your chips are smaller and easier to pass. Little compressed air. The air pump was a little tricky. I didn't use it this time because the chips were larger, and it doesn't have the velocity to clear them. So you really have to use compressed air in this case. And just also a little lubrication keeps things from binding on the end mill itself, and also just makes the cutting easier. Maybe
Keith Allen's trying to get some
sticker
free Winston
giveaway.
Make cards. He knows about the Winston Make cards. Did you
First
make
of all,
extra?
the only giveaways that I'm doing right now are for the dog tags, and I need to make more of those. That might come up as a second video on this channel. Just showing off my workflow. I'll do like a Jimmy DiResta style silent type video. Can I get an autograph from you? Yes, you can have an autograph.
You got it.
All right. So just really quickly to recap.
In fact, there's some. I think I haven't talked to Winston about this, but I'm planning to get some stickers coming out. I don't know if I feel like he's also getting stickers after that workbench con.
I'm trying to get stickers, but my graphic design friend is really flaky, so I might design them myself, which means they'll come out really crappy.
Your graphic
But
design.
I
mean,
will
my
have stickers.
logo is still rough, so.
So yeah, quick recap of Fusion 360. You have different workspaces: modeling, CAM, other stuff that most people don't use. In the modeling toolpath, you start with a 2D sketch, and then from that sketch you can extrude or revolve or just otherwise create 3D geometry from those 2D sketches. Same way you do it in SketchUp or any other program. Just the benefit is you get a parametric environment and a lot of really great tools to manipulate your models. CAM workflow, recap, you create a setup that defines the material, the volume we're trying to cut, the orientation, and you apply toolpaths based on whatever you want to do. And the biggest single thing I can recommend you do, just because I came from a different modeling environment, is in your preferences menu, go down here, and your pan, zoom, orbit shortcuts, I move them off of Fusion to SolidWorks. So when I'm navigating and I'm panning around, that's all middle mouse button.
Oh man, that's the most useful thing you've taught me yet.
Like,
God, I
holding
missed
down
that.
Shift and middle mouse button, you can zoom in. Control, you can translate. Just for me, it feels a lot more natural than the
It's way more now. That's the
Autodesk
way to go.
Inventor
That's
Fusion
great.
setup. So I try and save the best for last.
That just blew my mind. I gotta tell you, that's fantastic.
All right. So I'll be at Maker Faire in May. Let me know if you're going to be there. George, I know you're going to disappear for a couple weeks.
I'm heading out to Egypt tomorrow, so see you all later.
Yeah, so it'll be at least 2 weeks before our next FusionSide chat.
Yep, that's for sure.
Text us or leave a comment on Instagram. Let us know what topics you think we should cover. And keep in mind, they should be pretty basic because George has to be able to follow along.
I gotta follow along. Winston's gotta teach it. Let's keep it.
And thanks for coming out, everyone. And until next time.
Thanks again for watching, you guys. Take care.
See ya.